URL otherwise, just in case you want to look at something. In the source, there's a slides directory that contains some Sphinx docs. The build directory is in there, so if you want to look at the HTML directly, you can. You don't have to build it. Or if you like restructured text, you can look at that too. All right, I'm going to go ahead and get started here since, as I said, I'm a little bit concerned about time. My name is Randy Syring. I am Chief Executive Developer of Level 12 Technologies. I'm going to talk today about some of the experiences that we had basically with not having the right set of dependencies in production and continuous integration environments, and what we ended up doing, the tools we ended up using, the structures we ended up using to solve that problem so that our developers could be confident that we were all running on the same set of dependencies. Level 12, we are a web and database development shop that uses solid engineering, proactive communication, and modern development practices to make our customers really, really happy. I made this joke earlier, so if you're in the other one, I apologize if you heard this before, but our customers really don't know that they're happy. All that they know is that their software works and that they're upset about other things, but that's okay with us because the stuff that we're building works. So my code, like your code, depends on other code. Other people change their code. My code breaks, and I become angry. So the problem that we had in particular was I would go to work on something that I hadn't worked on for maybe 3-4 months, and I would update the code and I would run the tests and they would fail all over the place. And I would be angry and I would go to my developers and I would say, why are you guys committing code that breaks? And they would run the tests and they would go, the tests aren't breaking for us. And so we're like, okay, what's going on? So dependency problems, right? My virtual environment was 4 months old. They had updated things along the way, and the way that we were tracking dependencies, it may not have been in a direct dependency that we had. It may have been in a dependency of a dependency that it broke, and we didn't have any way that we were tracking all that stuff. So we know that good developers communicate dependencies to other developers once. Great developers continue to update other developers about dependency changes. We were not being great developers, and that had to change. So one of the things to be mindful of here is that apps and libraries both have the concept of dependencies, but there are important distinctions between these two things that use dependencies. Libraries usually have little control over how, where, and when they're installed. They want to be as compatible as possible for as long as possible, and they want to keep you away from dependencies that are known not to work, not specify things that you have to work. So for instance, if I have I'll just wait because I have an example of this. So dependency specs should be defined in your setup.py install requires. They should specify the needed packages, and you should only include version numbers to avoid things that are known not to work. So here's an example of what Flask does. Flask depends on these 4 libraries and it has minimum versions. These specifications for Flask are used on a wide variety of applications in a wide span of systems, and the author of Flask doesn't have to worry about any of that. He knows the very basic minimums that need to be installed, and so those are what he specifies. He also, because we don't currently have a way to specify requirements files in libraries, it kind of goes through the whole setup.py and distutils and all that stuff, because installing dependencies requires your usage. I guess it wouldn't require of it, but it's easiest if I can pip install something, that's easy, right? And in order to do that for a library, you have to install it here. As far as I'm aware, pip install, there's no way to tell it, hey, after you install this library, or even a library developer, there's no way to tell pip install use a requirements file. Is that true? Does anybody know a different way to do that? So the only way I'm aware of to reliably indicate this is in setup.py in the install requires. But applications are different. Applications should have more controlled deployments. They need a guarantee that known working versions of libraries are shared across environments, and we have different dependencies based on environment. So for instance, my production environment doesn't need my testing libraries like nose or my development libraries like Sphinx or piprot or anything like that. So enter pip requirements files. This is where for an application we want to specify what dependencies are needed at the application level. Our take on this was to stop using install requires in the setup.py file and instead use pip requirements for all of our applications since we have more control over those deployments. And in our case, we are not doing any kind of install from a package index for any of our applications. Our applications are always checked out to a server. And then we install dependencies from there. If you have an application that is going to be checked out and installed by pip, then this would change for you. So, did everybody know that you can nest requirements files? I had one. Okay, so you can nest requirements files, and so what we realized is that across all of our environments we shared a certain set of dependencies, but in testing we added others, and in dev we added even more. So for the devs Linux top level configure requirements file, it would look like that first example. All is basically usually everything that's going to be installed in production. Testing is going to include things like nose, and dev is going to have Sphinx. In production, I'm only going to use all, and then the reason that you have PyMSSQL there and PyODBC is that on Linux, when we connect to Microsoft SQL Server, we're using PyMSSQL because the PyODBC implementation to Microsoft SQL Server we were having problems with. So these are examples of our top level requirements files. Our top level requirements files only list app dependencies. They don't list dependencies. And so if we're going to depend on Flask, it's just going to have one entry of Flask. We're not going to duplicate Flask dependencies there. And then, you know, I don't think any of those other three libraries have other dependencies. Maybe they do, but you know, you'd get into a nested problem there if you wanted to list everything. So top level files only have what the developer is specifying the application needs at a high level. So our file structure looks like this. For a typical Python project, you have a requirements folder. Inside that requirements folder, you have an includes folder. That includes folder lists all the various unique sets of dependencies, and then your top level files do use includes to bring in whatever it needs for that particular case. So production, as I said, only brings in all.txt and might bring in windows.txt. Dev Linux brings in all testing developers in Linux at the top of the file. We make a point, I guess I'll get to that here. So the install requires, as I said, has the same philosophy as the libraries. We're only specifying the versions we need and anything that's known not to work. So if you know there's a buggy, there happens to be a buggy library out there, and from .1 to .13 it was broken, then you might put an exception in there for that. But otherwise, it's usually the bare dependency or a minimum version requirement. We only list the app's dependencies, not dependencies. We use -r to include files and therefore easily support different development environments while not having a lot of duplication in our individual top-level files. This can be useful for installing new environments, but with possibly untested dependency versions. So here's really the problem that comes in with this. If I have an application and I use one of these top levels to install my development Linux environment, and or even worse, let's say it's production. So you know, we have a production file, and it just so happens that in the 2 weeks between the last time I installed on my development machine and I use that same file in production, somebody releases something that breaks. Well, now my production environment is installing libraries that have never been tested anywhere. And so that's really the big thing that we're trying to avoid. So mostly these files are useful for developer intent. It is helpful too, especially the CI testing. If you have a continuous integration environment set up, you can actually set up 2 continuous integration environments. We're going to talk about snapshot files later. One would test your snapshot file. The other one would test your high-level CI testing.txt. And the benefit of doing it that way is all of the installed requirements would come from a package index like PyPI. And so you might actually have your continuous integration server end up catching some breaking changes that you might not catch in your development environment because you're not updating it frequently enough, if that makes sense. Any questions so far? Okay, so top level files are not enough though. So far, based on what we talked about, I can ask the question, what libraries do I have installed? I can get this in two formats, using pip list or pip freeze. I can also ask the question, do any of the libraries that I have installed have updates available? Pip list-o will give me anything that's out there that has an update. I can ask the question, how do I get libraries installed from this app? And the answer to that is to pip install using my requirements file. The questions that I'm having problems with though is, do the known working libraries for this application differ from what I now have installed? And how do I communicate the exact library versions I am confident are working with this app? So in both of those situations, what we've talked about so far does not solve this problem. Enter snapshot files. Snapshot files are simply a pip requirements file that has different semantics. These files represent all libraries with exact versions numbers known to work for a given app environment. If anybody does Ruby, this idea is very similar to the gemfile.lock. This matches. In our use case, we usually have the snapshot file match the top level name, except it has a .snap extension. And these files do get committed to version control. So this is how I know what is the expected development environment for, what is the known tested list of dependencies for production? What is the known tested list of dependencies for my local Linux development box? A snapshot file, if you have a production.txt and you pip install that, the production.snap file that you'd want is going to look like this as of about an hour and a half ago. So we've updated the file structure a little bit. I removed some of the includes just for the sake of brevity, and you'll see now that we have a couple snapshot files sitting right next to the top level dependency files. So the question is, how do you work with these snapshot files? The first example there is how we create snapshot files. They're simply output of pip freeze. And how do I test a snapshot file, or any requirements file for that matter, to see if any of its dependencies are out of date? So there's a tool here, piprot. You'd have to pip install that. That would actually go in your developments.txt requirements file. Once you have piprot installed, that command would tell you, are there any requirements in that snapshot file which have updates on your default package index, which is probably PyPI. How do you compare your installed libraries to a snap file? Well, this is pretty easy since snap files is just text. Since you should have your snapshot files, at least in what I'm promoting, since you should have them in version control, the easiest way I've found is simply to overwrite the snapshot file that exists with my current environment, and then do an HG or a git diff to see what changes are in there and make sure that everything that's updated are things that I'm expecting. If you want to test your production dependencies to make sure that they are accurate and that all of your tests are going to pass, you can make a temp virtual environment. That command is from a virtual environment wrapper if you're curious. It just creates a virtual environment that when you call deactivate, it'll automatically get rid of that virtual environment and all its files. So make a temporary virtual environment, pip install -r on your production snapshot file, pip install -e dot to install the current install the current application. I usually run a help command here, and the reason for this is because I once ran into an issue where I actually had decided to use a file in my production that I needed in production that was actually kind of from testing. I used one of the helper libraries, and so what happened is when I pushed it out to production and I updated, I had some breakages, and it was because it was actually the testing file that had the requirement, not production. So usually here I at least try to run a single command to make sure I get no obvious runtime dependency problems. From there, include the testing tools and then run your tests. So the two questions that I asked initially that I have question marks after are now answered. I can do both of those things. It's still a little bit handsy. There's a couple different commands involved. There's some things that are harder to do that probably could be easier. I have visions of grandeur of a PyDeps tool that would take into consideration this fact that I've got three kind of things that I'm trying to keep in sync. I have my current virtual environment, I have the snapshot files and my top-level requirements files. And then I also have PyPI and basically what's happening in the rest of the community. So I thought it would be great if I had a command that just said PyDep status. PyDeps understood all those 3 different paradigms, and it could say, hey, your current version, your current virtual environment version of this package, as well as your snapshot file, is not out of date with PyPI. It could say this snapshot file is out of date with your current virtual environment. It's missing these 2 packages. It could say the snapshot file has some library in it that you no longer have in your virtual environment. So it'd be really nice to have some of that stuff automated. And then support stuff like just doing a snapshot file, which would be easy. The fun thing I think would be is if it was smart and didn't just do the text-based representations, but actually understood packages and versions. That way, if the snapshot file was in a different format than what pipdiff was, we've had some issues with. We used another tool, and I can't remember the name of it, but basically it had a slightly different format because it sorted caps first, whereas pipfreeze sorts without taking into consideration caps. And so these 2 tools, every time you'd overwrite the file, the diff was meaningless because it was all over the place. Okay, any questions from there about requirements file, top-level requirements file, snapshot files? What's the difference when you'd use what? So pip itself, you can set up to use alternative indexes, that's true.
So it read the same file, so it's the same thing?
Yeah, pip is going to read the, basically what's the specification, what's the name it's looking for. And then there's commands that you feed pip or environment variables to tell it, here's some extra indexes you might want. So if you have, in your environment, if you have a local development index that you keep updated, then you can configure pip on a machine level to try PyPI first, and if it doesn't find it there, then look for extra indexes before it fails. Is that helpful?
I said pipdeps, actually PyDeps.
Oh, sorry. So just to be clear, PyDeps does not exist. PyDeps is my program that I hope to write one day, or maybe install or inspire one of you guys to write it. Yeah, sorry, I should have been clear about that. PyDeps does not exist yet. So we also ran into the situation where I was sick of having to have development tools installed on my servers in order to get the packages installed correctly. Sometimes that was easy because you had packages that would provide wheels or eggs, but then you also had the issue of, what was the other issue I was running into with that? Well, I can't remember now. I'm off track. But so basically, it was continuous integration. We'd have integration tests fail because PyPI was down, and we didn't want to keep a local package index. So since I was in the Ruby world, I asked what they did, and they've got Bundler, right? And one of the things that you can tell Bundler to do is to basically install all of the gem files in a local folder, and then you can commit that with version control. And I thought, hey, Python's got wheels now. We can do all the compilation and prepping that we need on our local development machines, and then install those wheels in a special folder in our projects and commit that with version control. And when our continuous integration server needs to pull files, it no longer pulls the files, or it needs to pull packages, it no longer pulls the packages from PyPI. It looks in the Wheelhouse, and if it's not in the Wheelhouse, it breaks. So that means that when I get to production, when I install from the Wheelhouse, and I'm pretty confident at that point that everything I need is going to be in the Wheelhouse, and my production servers no longer have to have build tools. So here's some example commands of how to update the Wheelhouse. To build or update it, once again, it's just a typical folder. There's nothing special about it. It's really the command that you use with pip that makes the big difference here. So I'm giving you 3 examples here. Number 1 is updating the Wheelhouse. Number 2 is how you install from the Wheelhouse. And that third command is to view installed packages that are not in the Wheelhouse. So any questions about wheels or wheelhouses or why you'd want to use them? Okay, any questions about any of this? Sure.
This reminds me of sort of a dark period in the Java world where you'd have in your source tree a magic lib directory with 1,000 jars in there.
Yep.
Version.
Yep.
So are we just going through that same period?
There is a sense in which you are doing that. So one of the disadvantages to this is that you end up with, you do end up with stuff in your wheelhouse that's old. One of the ways that we combat that is the snapshot files. You know, you're not going to have 5 listings for different Flask versions in your snapshot file. You only have one. So whenever you go to the snapshot file, or whenever you are viewing your commit, prepping to commit something, and you notice that you went in and you changed the library in your snapshot file, you have to think, hey, I need to go check the wheelhouse and make sure that I deleted that old version. So there is a sense in which, yes, we are kind of reverting back to that. There's other ways to solve this problem. You could use a local index, a local,
Like an artifact repository?
Yeah.
With version things that would be fetched recursively.
yeah, exactly. So you could do a local install if you wanted to, like that. So instead of committing this stuff to version control, you'd kind of have your own private one that you were compiling stuff and pushing stuff out to. And then if you were sure that your production environments were going to run, we're going to use those indexes, that would also work. The reason that doesn't work for us is that my customers, none of them are really Python shops. They don't want to set up more infrastructure. I'm lucky usually to be able to get to do most of my development in Python anyway. So this is an easy way for us to get the right versions of dependencies out to the servers. Our code's there anyway. Like I said, we all of this stuff on our production machines we check out. We have a tag that we make for that production branch in version control. And so I know that all of the files I need are going to be there in version control. Everything I need to run that app is in version control.
Could you use something like an external, what is it, modules, like, well, actually, I guess it's a Git concept. We've got one repository referring to a specific version of another repository. And just have the wheels in a repository that's separate from the source code.
Sure, I think you could do that. Why would you want to do that?
Well, it's just that if the source code is kept in a clean repository, then diffs are always light and efficient. That if I want to get like the patches between one time point and another time point, what I'm getting is largely just a text file.
Yeah, I guess in my experience, binary diffs are hidden. So we use Mercurial. Binary diffs are hidden, so they don't ever clutter up my view. And honestly, I like seeing in all one place when I look at a commit. I like seeing, hey, they updated the snapshot file, they updated the wheelhouse, they put a new one in, they took one out. Like I like having it all in one place, because my thing is I want to understand and communicate what's going on. And so even if somebody commits a wheel and they happen to forget to update the snapshot file, the next person that's looking through there goes, hey, why did you update a wheel that you haven't declared that you need? And they go, oh, you know what, I did need that. Let me go back and update it. So I personally like having it all in one space. For our use case, we haven't found any downsides yet, other than just managing the snapshot files, the wheelhouse, the top level requirements files all get a little bit handsy, and you've got to mentally remember to check each place. So if we ever get PyDeps built, that'll become much easier. And that would include things like, hey, your wheelhouse has out of date, or has out of date packages, you want to delete those wheels. That would be something that a tool like that could handle for you. It does make your repo bigger. The reality is, at least for us, that hasn't been a problem. It's still pretty small. Any other questions, thoughts, comments? Anybody thinking, this sucks, why would you do it that way? Because I'm actually interested in learning this. Like, I just put this together a couple months ago because of some of the problems we were having. So anybody solve these same kind of high-level problems differently?
Yeah, we actually build binaries for the entire component, the virtual environment, everything, all the whole thing up in the Dependency package, and then that's involved in the actual set up of the servers.
Really? What do you use to build that?
Where is build that?
The executable package? Or the executable?
The executable or so FPM actually rolls all for us. FPM is kind of the package manager, it's a CC project.
Okay.
You can build a Debian, you can build an RPM, basically from a set of static files.
Okay.
Just set up what your static file is going to look like. If you're deploying on a Debian basis, distro like a go-to or something, just slide it right into the directory where it's supposed to go.
That sounds pretty cool. So if I look at FPM, I can learn more about that?
You can look at my repository. I have a project called Dev8 that does
Debonate? I'm gonna take note on that. That sounds interesting.
Get ready.
Yes, sir.
You might, they'll take that in hall, so we can go ahead and let it.
Okay. Yep, sounds good. Thank you.